neural network happened in 1995, or maybe a little bit before that. CNN went among a series of ideas that we were trying to, when we get to neural networks, we talk about it in details, to overcome the challenges of artificial neural networks. Before that was neocognitron by a Japanese colleague. It was not successful because he failed to just provide the learning scheme for it. This guy said, okay, this is the architecture, and this is the learning scheme, not just the architecture. And it was not like, so the idea was there 1995, but nothing happened until 2006. The architecture was good, the learning algorithm was okay, but still you couldn't train it. It still would not go to an end, would go forever and ever and ever and ever until 2006. 2006, we got a fast learning algorithm for deep belief networks. Of course, the godfather himself was behind that, Jeff Hinton. So, fast learning algorithm for deep networks. First time ever that we figured out a way, how do you train a network that is so complicated? So many layers. How do we do that? So that was the breakthrough. And then when we have a breakthrough, other breakthroughs follow. In 2007, this came from Toronto, something came from Montreal. Greedy, layer-wise training for deep nets. That came from Benju and his team. So now we were complete. Now we had everything. Here, the work of Frank Rosenblatt in 1956 was complete. Now we know how to define artificial neural networks, put them together, make it deep, train it for a specific task, difficult task. So, but still, nothing happened. Why? Because somebody has to do this, make his hand dirty, or her hand dirty, and do it. Show for one case that is possible. That happened in 2012. With AlexNet. Then the euphoria and hype and AI and everybody running around is since 2012. Because for the first time, somebody showed that you can take a deep neural network and train it for a difficult recognition task like image identification on a large database of over 1 million images, cats and dogs and buildings and cars and humans and bicycles and everything, 2,000 classes. So somebody did it. Yeah, the theory was there, but somebody has to do it. This is engineering work. Theory is nice. Theorems are good, but who does the job? Who takes it and applies it on a real-world problem and say, because in order to do that, you had to work 2 years to get to here. It's not easy to run an experiment with an architecture that nobody has tried. Nobody has tried. You don't even know how to do it. For everything you have to, and most of the code that they wrote was then afterwards available to everybody. Because everything that you do is pioneering work. Unbelievable. So, okay. Enough history. So, what are the main tasks? We don't have a clock here. What are the main tasks for AI? We will go through all of them virtually. I want to go through all of them. I want to go through the history of AI. Just go one by one and see why did it take us 70 years to get here? Well, almost 120 years to get here, starting from Pearson. So we will hopefully figure that out together. So what are the main